Alright guys, hello. Welcome to Asynchronous 7th period. Today we are going to begin our physics unit. And literally, physics, if you are unsure of what we're talking about, physics seeks to explain everything around us, how things move. And you might have heard things like force, motion, and energy. That is what we're talking about when we're talking about physics. Alright, so literally our is going to begin with what is energy. So we're going to do some Cornell notes, and our topic is what is energy. So as I'm doing the notes, you should take them with me. You may pause at any time if you need to continue your note taking. So, what is energy? Have you ever thought about what it is? What is energy? Well, in physics, energy is defined as the ability to do work. Meaning, if you want to get something done, it doesn't matter what it is, even if it's your heart beating, you need energy to do that. And when things get done, you have been using energy. Alright, before we move forward, we're going to talk a little bit about the law of conservation of energy. And I don't know if you guys remember, but we've already talked about the law of conservation of mass. And if you remember correctly, the law of conservation of mass said that atoms cannot be created or destroyed. They can only rearrange themselves to create new molecules or compounds, meaning engage in bonds. But we don't lose anything in that process. And it's the same with energy. Energy cannot be created or destroyed. But it can change from one form of energy to another. It can change or transform from one form of energy to another. And I know you guys know energy transformations, or you probably are kind of thinking, ooh, I've heard that before. You have. This is, like I said, a review, kind of an intro to physics and reviewing things you've heard in 6th grade. So we are going to start, if you said an energy transformation might be charging your cell phone and then being able to use your cell phone for sound, light, energy, you would be correct. Alright, so there are two basic forms of energy, or types. And I'm not sure if you guys remember this or not, but there are two main types of energy. And one is referred to as potential energy, and the other type is referred to as kinetic energy. All right, so what is potential energy? Anybody remember? I'm sure you guys, some of you do kind of remember. All right, potential energy is what we refer to as stored energy. In other words, it's not in use at the moment, but it can be used whenever you need it. Okay, so it's stored. It's there and waiting. So it's not being used. But has the ability to be used later because it's stored. Now, stored potential energy has the potential to be used and converted to kinetic energy. And kinetic energy is literally energy of motion. So when something is being done or getting taken care of, it's using that stored energy to actually do something, and that's the energy of motion, when things are happening. So anything with movement or using energy, and basically using potential energy, is kinetic. So when we transform potential, that's stored energy, and we start to use it to do some work, it becomes kinetic energy. So we could write an example here. For example, an example of potential energy. Well, where do you get your potential energy from? You get your potential energy from eating food, right? So your potential is you eat food. That's your potential energy. That gives you the energy to do everything that your body needs to do. For example, breathe. Right, your heart beats, you want to speak, you want to move, your body digests your food. All of these things, these are an example of potential energy from eating. You need to do all these other things. So you eat, and now, because you ate, you have the kinetic energy to digest your food, walk, talk, run, whatever you desire, because you have that stored potential energy from eating. All right. So those are the two types. We are going to go into a little bit more depth on or potential energy or stored energy, because there are different things you might hear when we refer to potential energy. So we want to make sure that we were all understanding the information. So we are going to further subdivide potential energy, or that stored energy. So potential energy aka stored energy, there are a couple of different forms of potential energy. The one we are going to mostly concern ourselves with, and that we are going to be referring to a lot, is what is known as gravitational potential energy. Gravitational potential energy is important because it has to do with the effect gravity will have on that stored energy. So in this instance, the higher an object is above the ground, the greater effect gravity will have on the object, right? That gives it the potential energy, or gravitational potential energy. And we're going to greater the gravitational potential energy. To make this real simple, the higher up something is off the ground, the more gravitational potential energy it will have. So if I put a book all the way on the top of the bookshelf as compared to the middle of the bookshelf, the one that has been put higher up, so the one at the top of the bookshelf, is going to have more gravitational potential energy as it converts potential into kinetic when it falls off the shelf. Alright, so let's just keep going. Let's look at an example of this because this is the one we'll work with the most. So let's just do it with, we're going to draw a little tree here with some apples on it. And we're going to use this to talk about our gravitational potential energy. Well, here's my tree. And here's a little apple. And here's an apple. And way at the top up here is an apple. So this is apple, let's see. This is apple A, this is apple B, and this is apple C. So based on our definition of gravitational potential energy, which of the apples would have the greatest potential energy as it's sitting in this tree? Well, if you said apple A, you are correct. So apple A is the highest up, right? The highest one in the tree. And therefore has the greatest gravitational potential energy. Gravitational potential energy. So the higher up you are, the greater your potential energy as far as gravitational potential energy. I'm going to add that. The higher you are, the higher, the greater the gravitational potential energy, and I wrote it as GP, gravitational potential energy. So with gravitational potential energy, no, it's stored, you're not moving, but you're high up off the ground. For example, if you are a rock at the top of a mountain and you are not rolling, you are sitting at the top of this mountain, you have high, great potential energy because of the fact that you are so high up off the ground, right? So a rock that would be sitting on the ground below you has no potential, gravitational potential energy because it's already sitting on the ground. It's not on the, not way up above, not high up. All right, there's a couple more that we're just going to touch on, types of potential energy, before we move forward. The next one would be chemical potential energy. Now, we're going to need to know some of these as we move forward, but when the discussion is about potential and kinetic, in general, we're talking gravitational potential, so that's the one that we need to know for this lesson the most. All right, chemical potential energy comes in different forms. If you say food, you're absolutely right. The food you eat is chemical potential energy. Why is it chemical? Because it's organic, right? Most of it, not all of it. But for example, glucose of C6H12O6, or even table sugar. Any of these have chemicals, made up of chemicals. Those gives you chemical potential energy. Another one that falls under this category is gasoline, for example, or even any fossil fuel.
If you have not submitted your attendance, please do so at this time.
In other words, gasoline and fossil fuels are all organic. Remember, they have that CH bond. The gas or methane gas is CH4. So that's just an example. And one last one that we're going to throw in here is batteries. Batteries have stored or chemical potential energy. And if you've ever looked at a battery, they are made of nickel and cadmium. Those are two examples of elements that can be found in batteries. But those batteries store energy. They have potential energy. And when you hook them up to a flashlight, for example, or anything else, then you can convert that chemical potential stored energy into kinetic energy, energy of motion. And then we're going to, one last mention, we're going to mention our elastic potential energy. And our elastic potential energy is things like, and I lost my rubber band from this morning, but a rubber band is a great example. So you have a rubber band, and when I pull back on it, I have a lot of elastic potential energy. When I release that, that's going to convert into kinetic energy, and boom, it's like it goes somewhere, right? The rubber band has that energy to move and do work. All right, so rubber bands are an example of elastic potential energy. Another good one that falls into this category are springs, like the springs in your pen that will make the pen work properly. The springs are in here. That's that elastic potential energy. So, potential energy is stored energy. The one we are mainly concerned with is gravitational potential energy. How high above ground is something sitting still or not moving yet? And that's going to be the higher it's off the ground, the higher its gravitational potential energy. There are other forms of stored energy like chemical and elastic, but our main focus will most likely be on our gravitational potential energy. So the kicker is that with stored potential energy, can be transformed into energy of motion or kinetic energy. at any time during the video. If you need to pause it to finish your notes, please feel free to do so. All right, let's look at an example of that gravitational potential energy. And the example we are going to look at is a roller coaster and the changes that occur, or the change off between gravitational and potential and kinetic energy. So if you were to, let's see if I can do this. If you were to look at my little cards, I have two cards here. I have potential energy. Oops, that's kinetic. I have potential energy and I have kinetic energy. All right, so this is how this works. I start, the higher up I am off the ground, the greater my potential energy. This object, let's say it's a rock on the top of the mountain. It's got extremely high potential energy, has no kinetic energy at all because it is not in motion. But let's say rock off the hill. So now that potential energy is being converted into kinetic energy. And gradually the rock is losing potential as it's gaining kinetic energy. When the rock is at its fastest, moving its fastest, it has the highest kinetic energy at that point and the lowest potential. It is a total trade-off. So from when potential is high, kinetic is low. As potential energy decreases, kinetic energy increases. At one point, they are equivalent, right? And one point in the exchange or transformation from potential to kinetic, those are equal, they meet. Okay, kinetic is high, potential is low. Potential is high, kinetic is low. Potential is stored, kinetic is energy in motion. When the object is at its fastest, its highest kinetic energy and its lowest potential energy. At one point when potential transforms to kinetic, they are equal at the midpoint, wherever that might be. And we're going to look at some examples here in a minute. So just so you know, potential high, kinetic is low. They are trading off, right? Trading off. Trading off. All right, so let's go back to our notes. Here we go. No, that's not what I want. I wanted this. No. Let's see, guys. Let's see. Where are we? I want the visualizer. Can I get my visualizer back? There. All right, here we go. Back to our visualizer. All right, so here we are. So we're going to, I'm going to go to the left side here, or maybe not. I'm going to the next available side. If you can use your left side in your notebook, please do. Mine's all messed up from my markers. So we are going to look at the energy transfer in a roller coaster. Okay, so we're going to look at energy transfers. Between potential and kinetic, and kinetic energy. Now, once again, one thing we need to note: when the faster you are going, the greater your kinetic energy. The faster an object moves, the greater the kinetic energy. All right. So keep that in mind as we do our drawing. So we are going to draw a roller coaster. I know some of you may have never been on a roller coaster. Some of you might not like roller coasters, but some of you might enjoy the thrill of the ride. And we are going to do some looking at how potential and kinetic energy are affected on a roller coaster ride. All right, for starters, is where do you think you would find the greatest gravitational potential energy on a roller coaster? Well, if you said at the top of that very first hill, you are absolutely right. Because the very first hill is going to be the highest hill on the roller coaster, period. But how does the cart go from here up the hill? How does the cart do that? Well, usually there is some kind of mechanics there. So there's something, a track and a machine pulling the cart up the hill. So machine, and you'll hear it, sometimes you'll hear it go click, 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 click as it's being pulled to the top. So a machine of some sort pulls cart to top. All right, as it's being pulled to top, it is gaining potential energy. So from this point to where it's all the way at the top of that very first hill, the highest hill, at this point it has its highest gravitational potential energy on this ride, whereas as it's being pulled up, it's been given potential energy through the machine. So it's gaining potential energy. Remember, we're talking about gravitational potential energy at this time. So, the highest hill so the very first hill is the highest hill, meaning that at this point, the cart will have its greatest potential energy throughout the whole ride. Okay, it's going to have its greatest potential energy throughout the whole ride. And then, of course, it will be going downhill. So as this cart, where it appeared, has its greatest potential energy, greatest gravitational potential energy, as it begins to move down the hill, it is obviously, that's where that switch off comes. It is transforming all that stored energy it got from the machine, bringing it up here. It's going to transfer that into energy of motion or kinetic energy. So the fastest point is the greatest in kinetic energy. Where is the cart going to be going the fastest? Well, once it reaches this first bottom, it's going fastest. So at the bottom of the hill, we have our greatest kinetic energy because it's moving the fastest. So as the cart moves from this point to this point, it is losing potential energy and slowly gaining kinetic to where it's mostly and totally kinetic, greatest kinetic. So We're going to indicate that it is as it goes down the hill. Potential energy is transforming to kinetic, right? And it continues to transform. If we are sort of midway, I guess maybe right here, if the card is right here, in the middle of the track between its greatest potential energy and its greatest kinetic energy, right in the middle, the midpoint is where both kinetic and potential energy are equal. Potential and kinetic energy are equal right in the middle of that trade-off. So that's at that midpoint. All right, so the roller coaster got all of the energy it needed, all of the stored energy, all of that gravitational potential energy it needed at this point to make it through the whole ride. It never gets any more energy boost. So this is where physicists calculate, okay, how much energy do I need to make it through the whole ride? So they want to make sure they have enough gravitational potential energy here to make it through all the ups and downs and circles and twists and whatever there is on that coaster. And that's how you build a roller coaster. Make sure you have your greatest potential energy here that will carry you all the way through. So once again, here is the greatest kinetic energy, right? Greatest kinetic, he's at the bottom of the hill, he's moving the fastest. Now here we go up the hill again. So what's going to happen now? So as the cart goes back towards the top of a little hill, even though it's not going to be the extreme greatest, but it's going to be PE up again, right? Potential energy will be up again here. Because here it has the greatest kinetic. Now it's converting back, remember? So now kinetic energy is converting to potential energy. All right, so as it moves up the hill, it's changing that energy of fast motion to slowing, but it's to storing that energy till it gets to the top of that next hill. And it's once again for this hill, at its highest potential, right? And then, so potential would be up here, kinetics up here, potential is the highest here at the first point, then it's trade-off 1 to 1. From potential energy to kinetic to potential to kinetic, and it's just a switch on and off until you fully lose all of your stored energy and you have converted it, then you're done. All right, once again, at the middle point here somewhere would be potential and kinetic would be equal, right? Because they're always equivalent at the midpoint. Any questions? I hope this kind of explained everything very well and that you do not have any questions. So this is going to be for your notes today. Make sure you get this into your notes and make sure you do the activities that pertain to potential and kinetic energy. All right, guys, have a wonderful afternoon and enjoy your 4-day weekend. Bye.